Welcome everyone. This is the VFX Master Program, lesson 5, I believe. Um, I'm going to continue talking about the flock of birds from the previous lesson, just something, a couple of more things that were missing from the video in the last session. So again, same topics as before. So I'm going to open the scene file that we were working on in the last recording, which is located here. There we go. This is what we had a bit earlier, right? So we kind of took care of swarm that has multiple leaders. They have to follow, each one of them individually or separately. But if you see on the video, and I hope you're watching the Planet Earth. I really hope that you're, going over the episodes. You will see that there is another. Let me just get rid of the volume. There's no need to hear it. There's another type of swarm or a different element that we would need to recreate to be able to fill everything in. So that's fine. We have this kind of effect. Okay, obviously it doesn't look the same as what I have play on my screen right now. But this is simply a system that has probably one leader at the moment. So it's a bit of an overall group behavior. Nothing broken up into subgroups. So if you just take your number of leaders and set it to one, or probably one, I don't think two will be the same. It will start to look like this. So that's not a problem for me. That's just not something we can deal with dynamics at the moment. But this is what I wanted. This is another element. And usually, right, this type of shots are broken into different passes. And I'm not talking about render layers like beauty and specular and diffuse. No, I'm talking about different elements, particle elements that we're going to be combining, and then it will give you the flexibility of editing each part separately, each behavior, and in the aggregate, then it's going to give you the complexity that you have in a shot like this one. So what I was looking at yesterday is that you see it's almost like they're starting from going from screen left to right, as well, they're closer to us. Then they kind of turn to the left towards the back, and then I can kind of see them going again. So they almost seems like they're going in probably in circles, but getting further and further away from us. So that kind of stuff. So it seems like it's very uniform motion from left to right and then screen right to left. They're all kind of going in a way that there's some obvious turbulence and random behavior in between, but the overall purpose of the group is just, moving from one point to the next. It's not like what I have on my screen where they're just kind of following someone that has some sort of behavior. They want to just be close to it. So that's what we're going to be adding to this one. All right, great. Just rewind a little. Remember, this is episode 1 of the Planet Earth series. It's called From Pole to Pole, and it just covers a little bit of each main topic from one of the, for each episode. So let me just get back to this point. All right, so we have this thing as a reference, just in case. So this is my scene. I have that. I'm not going to worry about it at the moment. I'm just going to open a new one. All right, cool. We want to have the same amount of flexibility as we had on the other one, so controlling same idea, right? So for this element, what can go wrong? What can be changed? Things that can be changed will be probably the same thing: amount of birds, the speed where they travel from one side to the other, probably some overall turbulence. Just for now, I think we should be fine. This is not going to have a leader setup like the other, but it's going to be using goals in a different way. So what I'm thinking for that, for flexibility's sake, is to probably use a piece of geometry that I can shape and then have the particles flow along that area, along the surface. It can be done in a couple different ways. I will show you just one setup just to talk about goals. Remember that I'm trying to incorporate and mix in things from the FX Power User Program 2017, and in this case, the FX prototyping. Like I said in the other lessons, don't take this list so literal, right? It's going to be topic by topic by topic in order. That's boring. I know exactly what I need to do. I know everything that is there. I wrote it myself. So I know what the topics are. I'm not going to leave anything behind or anything out. But I want to start mixing things. It's going to be more interesting. For a more detailed topic from topic courses or videos, refer to the Power User Program that you already have access, all of you, which is right here. Right? Cool. All right, so that out of the way, I'm going to go ahead and create a piece of geometry. Anything you want. I like polygons, just, I don't know. It's up to you. So you can use a NURB, but I think just use polygons for now. And I'm going to make a simple, let's say, just a simple plane. This plane, I'm just going to scale it. I don't need my grid. So I have this piece of geometry right there. Cool. All right, so this piece of geometry, I'm going to have it emit particles. So I'm going to select it. I'm going to go to the effects menu like we've done before. There's nothing to recap here. Emit from object, surface emitter, and here we know what's going to happen already. I'm going to give myself a lot more time to play. There's the particles. I'm going to grab my emitter and I'm going to get rid of, this is like what I used to call like the pre-flight check kind of thing. So I'm going to get rid of the speed. Things that I'm almost going to do. I'm going to grab my particles and set the conserve to 0.98. Sorry, okay, there we go. 0.98. And that's it. I'm just going to get, and I'm going to increase the rate to 1,000 particles a second. And I get what you would expect. Just particles on the surface. Right? Cool. Now, how can I turn this kind of feeling? And my idea is just to have it sideways like that. Okay? And obviously represent a bird with each one of these points. And I want to have them move. Sorry, let me just hide the polygons. Okay, so I want to have them move from screen left to screen right, just like here. Okay, and then at towards the back, I want them also to turn, and I want to have flexibility over the path. I think I already said we're going to talk, give control over the amount of birds, the speed with which they travel, some turbulence, and kind of random motion along the way. But I also want to be able to have flexibility as far as the shape and the overall shape where they're going to be traveling. It's not going to be a straight plane like this one. I should be able to deform it and have different patterns of motion. So I want to use this as something that my client can model himself. They can just tweak it quickly, just the overall shape of this piece of plane, and then have the particles move along that surface. So he can describe himself the trajectory which the birds will have. I think, like I said, it's this kind of stuff that they love to have, the control. And even if he doesn't do it himself, he can have someone with very little experience just model this piece of plane, and then you take care of the rest. At the moment, the particles are not moving. You may think straight up, why don't you put a force field and just move them from one side to the other? And that's if you just wanted a straight line. Or just going from point A to point B, that's it. But if you want them to follow a curve or a surface that your client's going to give you for the trajectory, he can put cameras. He can pre-visualize, He can previs this scenario without particles. He can just take the plane, you tell him, take the plane, shape it any way you like, put your cameras, do your camera moves. When you're happy, send it to me and I'll make sure that the birds are moving along that surface. That's the kind of prototype setup that you want to do for them. So with that being said, then the fields are not going to really do it for me. What I do want is particles to respect the topology of this piece of polygon and move along that surface. And that's quite simple to do. If you just grab the particles and shift select the polygon, then you can gold them to that surface. On the previous lesson, we gold the particles to another particle and gave us a flock of birds and some random behavior, which is fine. Right now we're going to gold them to the surface. So I hit create and it's fine. You would think, well, why would you gold them if the particles are already stuck on the surface? And that's not really true. They're not stuck on the surface. They're just being born on top of the surface and that's it. But if this surface was deforming or was animated, moving around, the particles would just stay where they were born. And we can actually prove that. Right now I already created the goal, so I'm going to get rid of it. Get rid of it now. I'm just going to turn it off by setting the goal weight to 0. So right now there's no attraction between the particles and the plane. And if you see it just like that, then that's what you will say, well, but they're already stuck on the plane. And like I said, that's not really true. Because if I do that, sorry, I selected the particles. If I select the plane and just move it down, then I just get that, right? Get particles, whatever the plane is, but it's not really following the plane. You see the difference? So cool. You'll see now the difference if I gold the particles to this. So if I take the particles and put my gold weight back to, well, it was 0.5. I'm going to put it to 1. So there's 100% attraction. So the particles will follow the shape of the polygon. So I'm going to hit play right now, and then you get this. That's the default behavior. What happens is the particles will attach themselves to each vertex, or each vertex of the polygon. And if you have more particles than vertices, then particles will go on top of each other. So this will have applications in some situations where you want the particles on the vertices. In this case, you don't. You want them to be scattered all over the place. So first thing we need to do, well, what I wanted to do before I jump onto anything else, I just wanted to move my plane. And if you hit next, you can see that the particles are stuck. And you will see them even easier if I just set them to spheres. All right. So if I grab my plane and move it, as soon as I go 1 frame forward, the particles will get stuck on them. You see? So everything is, at least they're just respecting the surface. And if I deform it, it will do the same thing as well. So for example, if I grab, let's say, if I grab some vertex on this, or let's say I grab this row and I move it up, and I go 1 frame forward, you can see what I mean. So the particles are respecting that. Let me undo. One frame forward. There you go. All right, so it works fine. But like I said, they're not. I don't want them on every CV. I just want them to be placed all over the surface. So that's the first thing we need to fix. I'm going to put this back to points because it's cheaper to display. And to fix the situation, then all you need to do is, well, first of all, let's just go ahead and give ourselves a limit on the particle count, just for the sake of the exercise, just to begin. Let's just play only 1,000 points. So let's rewind, hit play. There's 1,000 points right there. All right, so to fix that, we're going to grab the particles. We're going to go on a per particle attribute, right? And we're going to add a few attributes. This is the first time we're going to do this. So this list, you've seen it like this before. We used it. We put expressions on gold PP. We put expressions on mass. But this list is not all the attributes that are per particle and that they can be used. Mine just displays the most common ones. But if you want to add some more and then just add more complexity to your shot, that's definitely possible. You just go to the General tab. And then here you will have under the Particle tab a long list of attributes. Everything with the double P stands for per particle. And what I'm looking for is goal U and goal V. Why goal U and goal V? Well, you should know by now that the polygons have UVs. Okay, so if you don't know what a UV is, then I will suggest you to read a little bit more on the Maya documentation or just Google it. It's very simple. but it basically describes, it's for texturing of the polygon, right? So it describes the direction, okay, of each polygon piece. So that's what we're going to be using, a goal in U and a goal in V. Right now, there's not being used at all, so that's why they stuck on the vertices of this polygon. So I'm going to select those two guys, and I'm going to add them. As you can see, they show up now on my list. So which direction is U, which direction is V? Well, then you can just verify that later on. You can just open the UVs of the polygon itself. So if you go to Modeling, UV Editor, and you grab your polygon, there you go. So you get your U and your V direction. There's nothing special. That's why I chose a polyplane, because it's a very simple shape, and I can still deform it, and it will still do a lot for me. So I think it's easier that way. So I'm going back to my particles, and I have goal U and goal V. And basically, all I need to say is for each particle to pick its own U and V position and place themselves whenever they like, all along this surface. So that's very simple. I'm going to make a creation expression, because that's a value, remember, that the particles have to get when they're born. If you want, later we'll modify that on a frame per frame, but right now I just want them to, when they're born, to choose any position they like on the V and on the U direction. And how do I know which values to use if I'm randomizing? How do I know how far this goes? Well, like I said, I'm going to have to go back here, UV editor. These UVs is what is called normalized, meaning that the UVs of the surface go from 0 to 1. Man, these Facebook notifications are annoying, huh? Jesus Christ. All right, so I get from 0 to 1 in each direction, so they're normalized. So I know that if I want a point to be placed in here, for example, this is UV position 0.1 and 0.1, and then 0.2, 0.3, and then if I want them, I can place them randomly in this direction and also in that direction. So I know that it won't go past 1 in each direction, so it's very simple. So back to the particles, back to the particle shape. Okay. So I'm going to find my goal U and my goal V on my list. There you go. Goal U, then we're going to say that it's equal to a random number between 0 and 1. Correct? This is one way of writing this, and that's perfectly fine. If you want to be a little bit more sleek and a little bit faster on typing, and you're a bit more familiar with the thing, you can just say goal V is equal, okay, to random 1. This expression here, aside from the fact that this stands for V and this one is for U, but aside of that, this expression and this expression are exactly the same. Here you type a lot less. Remember what we did on the previous lessons, where we didn't, if you don't type the name of the particle, doesn't matter, Maya will fill it in for you because it's already selected. And also, if you do a random function and you don't specify a minimum, Maya will assume always that it's 0. So this is a random number between 0 and 1. So these two things are the same. You hit create, you get no errors right here. You can see that now we have two expressions in this area. Let's see what this does. Because we haven't saved the scene, let's go ahead and save it. And this is going to be FX Master lesson 4, but this is going to be 5. Swarm as well, so that's fine. Beautiful. All right, let's see what this does. Voila, perfect. We have 1,000 points that are spread randomly along the surface. Nothing is outside. As you can see, everything is perfect. Everything is within range. You get guys that are really, really close to 0. And really guys that are really close to 1 and 0 from each direction. So that's perfectly fine. So we have one of the problems solved. Let's go ahead and let's make a little camera for us. Just create a camera. There it is. I'm going to look through it. So I'm going to grab my plane. I'm going to place it just so you see that this thing is respecting the topology, right? So I'm going to grab my plane, I'm going to rotate it, and move it. I'm even going to probably scale it. Actually, I'm upside down, but it doesn't really matter if you're upside down or not. I'm just gonna let's just do it like that. All right, so I'm gonna scale it a little bit so I fill my whole screen with it. There we go. Just excuse me 1 second. I'm gonna pause the video for 1 second just to get rid of this Facebook notification because it's insane. My Facebook is very active and god damn it, every 2 seconds I have something. So give me 1 second, I'll be right back. Okay, I'm back. I believe. Yeah. So Facebook is gone. All right. So basically, this is what we had. I'm filling the whole screen with the plane. Now I'm just going to go 1 frame forward, and here are my particles spread all over the screen. I can move out. I can move in. Perfect. So that's one of the things done. Now what happens now? I just want them. I want them to move from one side to the other. So for that, a force field won't cut it. Remember, I want them to respect the topology. I'm assuming that my director will go ahead and move and deform this poly piece as he pleases, right? To give some sort of a path to these guys to follow. So I'm not going to use forces. What I'm going to do is just find a way to tell Maya or tell my particles that take whatever position where they are and then move along the surface. When we saw the UVs for this polygon, once again, there they are. Let's say that a particle is born in the position, for example, 0.5 and 0. It chose that position. If I want them to move along the surface, I'm just going to have to add to that 0 something on every single frame, right? So my particle goes from 0 all the way to 1. Basically, that's all we need to do. We need to come up which direction I want these particles to move, and then just add a little bit of it on that same direction on every frame. And it's easier if I just show you. So I'm going to grab my particles. I can go, for example, just to see which direction. You can test it yourself. You can just put one value and then the other and prove if it's moving on the U direction or the V direction. But you can also, for example, grab the particles, grab one of them, go to numeric. God damn it, but why is this thing selecting itself? These menus are weird. Go to numeric. For the selected particle only, instead of showing me the ID, I can just tell them to go U, for example. And that's 0.750, and this is 0.764, meaning that this guy, let's just find two that are close together. This guy has a U position of 0.77, and this one 0.772. So this means they're on the same level in U. So it should be that this is my U direction. Let's just test if we change the U for the V. This is 0.4, and this is 0.7. So it means that the surface direction, okay, this should be 0, right? And somewhere here should be 1, almost 1. So this is V, and this is U. You see how useful the numeric thing is? Jesus Christ. Okay, cool. So now we know that the particles, in order for them to move in this direction, they have to move in the V direction. Another thing that I saw is that the particles are, this is 0 and this is 1. And if I want them to move from screen left to screen right, then you have to subtract, and it's a bit of a pain in the ass. I find it easier just to rotate this thing like that. So let's make sure that that's true. I'm going to redo my check. I'm going to go to my particles, and I'm going to grab this guy. Jesus. Something off with these menus, man. I'm not clicking, but it's selecting. Okay, numeric. All right, so my goal V in this section is 0.003, and let's pick one of these guys somewhere there. Perfect. So you see, now my V direction here is 0, and when I get to this side, it's almost 1. So now it's perfect. So we'll go from here to here. I like that. So points. Back to object mode. All right. So let's try that. Let's try and see if it's true. So let's just grab my particles, go to the particle shape, and let's go and edit the V expression. On creation, we're fine for now. They're born in a random position. All I want them is in every frame, take that position what they have, and then just add a little bit more to that value so they can start going from this side to that side. So if I'm going to be adding on every frame, then it has to be a runtime expression. As you can see, we don't have anything here. And these are expressions, remember, that get evaluated on every single frame. So I'm going to grab my goal V. And how do I tell it to add to itself on every frame a certain value? What you could do is the long way, which would be that the goal V is equal to the goal V plus, let's say, for example, I don't know, 0.05. Remember that these guys go from 0 to 1. So don't add too much to this. This is the long way of doing it, right? The short way is just to say plus equal 0.05. Again, this expression right here and this one over here is exactly the same. Basically, this tells to add to itself this value. So either way. Create. Perfect. So no errors, nothing. Let's see what happens. Look what they did. They're born and they travel. They're going really quickly. Let's just lower that number a little. But it works. So go to runtime. Instead of adding 0.05, let's do 0.005. Let's rewind and hit play. And beautiful. What do you have? There are situations, there are a couple of things that we need to solve. But as far as going from screen left to screen right, follow the topology of this is working perfect. Why do I say there's a couple of things to get rid of or to probably tweak a little? It's because when the particles get to the edge, they don't know what to do. They just kind of get, attached right there. The ideal situation, obviously, when you do a shot like this, you would never have the edges of the emitter visible. So you will do something probably more in this line. Let me rewind and hit play. So you get that. So you don't really see what happens at the end. It doesn't really matter. But because this is a shot that will have hundreds, if not thousands of birds, having a whole bunch of birds stuck on the edge of your emitter or your surface is not really a good idea. That's going to start building up memory. It's going to create render issues. What you really want to do is just have the particles, when they reach the edge, just die, disappear. That'll be the easiest thing. Now, how do I do that? Because so far we have done only live forever, and we have done random range. You could do a random range and kind of estimate or guesstimate how long it will take for the particles to move around. But if your client changes the speed, then you might have birds disappearing in the front of the camera, and that's horrible. You don't want that. So that's not really what I will advise you to do. What I will advise you to do is to do something that is for the first time we've done it in the course, is to switch this from live forever, to lifespan PP only. As the name implies, is a lifespan that each particle will have, different from one another. And that means that you can put an expression on this. So I'm selecting lifespan PP. I'm going back to my expressions. And the advice that I give everybody when doing this kind of stuff and starting to do expressions is just to tell yourself what you want to do or what you want the particles to do. And always ask yourself the first question. The first question that you're going to be asking is this expression going to happen when the particle is born, right? Or is it going to happen on every single frame? That's the first thing, because that's going to tell you if it's a creation expression or if it's a runtime expression. That's the first decision. So what happens? Well, I need to tell Maya that when the particle reaches goal V1, right, a value of 1, then the life of that particle is going to be 0. That's what I'm telling you by saying things to yourself the way you want them to Maya to do it. So I want Maya to grab the particle and move it along this polygon, okay, all the way until they reach position V1, adding to itself until they get to the edge. And once you get to the edge, I want you to die. All right, well let's write that down as an expression. It's very simple. So if I want Maya to check every frame, because Maya needs to figure out where each particle is at every particular frame. And if they reach the edge, then they die, right? I pretty much said the whole expression already. So I'm going to grab my lifespan PP, which is right here, and I'm going to make a runtime expression because it's on every frame. Okay, so I grab my lifespan. I will advise you to put your lifespan, in this case, after the movement of the particle right here, right? So I'm going to paste this. And basically what I want to say is, what we basically said on the words that I actually was just telling Maya, right? I want, if the particle reaches goal V1, then die. And I'm saying if, you see, it means there is a condition. So some of you, for this kind of stuff, for some of you might be very simple and you might be bored of this part. Just give me a couple more minutes and you'll be fine. It's for the guys that don't really have experience with this. So I said if, and I will put if. It's simple, right? If, bear with me 1 second because this keyboard is a different keyboard and I'm not really sure what my, okay, brackets are. So that's not the bracket. That's my bracket. All right, cool. You need to open brackets for an expression, with a condition, I'm sorry. So I say if you want to make it nicer looking, there we go, we do that. So if the particle, not the life, but I said if the particle's position in V, or goal V, right, this attribute, reaches 1, then the life of the particle is 0. So perfect, so I can grab and say, you can grab this if you want, and then you can say if goal V, let's say, is greater than, you can say if it's equal to 1, but I think in this case it's better if you say if it's greater, let's say the 0.99. Yeah? If that's true, okay, let me just give you 1 second here. Let me just get these things a bit more organized. All right, cool. So if you were to write it down in a straight line, right, you will say if the particle goal V is greater than this, right, then, but you will type then lifespan PP of the particle, right, is going to be equal to 0. I mean, this is a life, right? So if I said life 0, it's just basically the particle is dying. Correct? Then to type this, and I'm a bit, I hope I'm not too bored with this part, but this is something that you're going to be doing quite a bit. So like I said, then if the particle, if this is the condition, okay, and it goes in parentheses like this, then you put brackets, and then you grab this part, you put it there, and then you don't put then, that's just something I put to help you out a little bit. You hit edit and there's no mistakes. So basically what you're specifying in here is the condition. If this particle moved enough to go past a point in V, which is greater than 0.99, almost the edge of the surface, and this is something you can change later, and even put it as a control for someone to dictate when the particle will die. And that's something I'm going to use a lot in my course. So don't worry about it if it takes a little bit of time to pick it up now. But basically the condition goes in parentheses, and then what's going to happen, it goes into brackets. So if this is true, then the particle dies. And if I hit edit, no mistakes in here. Now, one thing that we're missing is what happens if not. What happens in most, actually, for the 99% of the situation might not happen. This might say no. So what happens then, right? You could say here on this expression, you can say, well, else, if this is not true, then, okay, then you can say, well, let me just put my brackets again. Then you can say, well, then then the lifespan of the particle, for example, I don't know, is 1. Okay. This is valid. You see, there's no mistakes, but I don't advise advise you to do this kind of stuff. This would work, it will look kind of funky. It's not really elegant solution. Because what happened in this case is that the particle will get a new lifespan on every single frame. And in some situations, when you start getting more complicated with more expressions and more conditions, you don't really want to reassign the life of the particle on every frame. What you want to do, okay, is on creation, when the particle is born, give it some life. Right? So I'm going to grab this. And when the particle is born, I say, well, you know what? Like all of us on this earth, right? We'll get a lifespan. Sadly, we don't know how long it's going to be. But you can say, well, this particle will live 10 seconds. 240 frames, for example. You will see later if it's enough or not. So when the particle is born, it knows how long it's going to live, and perfect. That's something that is going to move in one direction. That the particle knows that. So, but you can all of a sudden think of this as an accident on someone's life. When you're born, somehow I believe that's my belief. We have a particular time and day that we're going to die, unless something happens before that, right? So think of this as the bus that will run over the particle or whatever, right? A disease or something. This is a condition that this goes and tells true, then all of a sudden the particle dies, regardless of the particle having 5 seconds left or 3 seconds left. The only thing that is, if this doesn't happen before the 10 seconds, then the particle dies because it got old enough and died, not because of this. So the particle will die one way or the other, just like life, right? So perfect. So we get the creation expression, and let's see if that's true. One thing to keep in mind, and I hope that your mind already for SoundFX TD started to work that way, is that we have a set number of particles specified right here. And before we did these expressions with lifespan, then we got 1,000 particles that reach the edge and nothing else comes out because the particle is still alive, they're just on the edge. If you remember what I said in the previous lessons, when you're using max count and one particle dies, then one particle gets born on it to replace it. So if that's true, then we get particles to reach the end and die. The particle count will go below 1,000, and then new particles will be born and then move. So let's see if that's true. And it is true. You can see that we have more density here because we just started, but then as the particles start to die, then you start to get new particles born everywhere. So at least the system works. You don't see green dots stuck on the edges. So this is an efficient system. It's a system that kills particles when they're not visible, when they're not needed, and it replaces it with particles if you need more. If you don't need more, then fine. But I think for now, you see, and it's endless. This shot can last 100 years and it will still work. The only problem, and I wish I had you guys, sometimes live to test you with this one. What is another problem right now? If you compare it with this, is that this shot, you don't see birds being born in midair. They're coming from the ground and they're moving up, or they're coming from the left. So we need to do something here and avoid having particles being born anywhere on the screen, because you don't want, if you were to instance something in here, and if I switch it to something else other than a point, okay, and I put spheres, it'll be more noticeable. You get spheres being born right in front of your eyes. So you don't really want birds just materializing in midair for some reason. That's not that kind of movie. So how do we avoid that? Well, not that hard. Put that back to points. One thing that we haven't done is save. Let's save just in case. Great. Move out. And what do we do now? Well, I think what the condition that we can put is say, I want particles only to be born on the edge, down here. Yeah. on this edge, for example, right here, and I know that this is the beginning of the V direction. So how do I tell particles only to be born there? Well, you can't do that. But what you can say is, if you're being born on this area, then don't be born at all. That's something that you can say. So let's go ahead and try that. Again, this is an expression that's going to be runtime or creation. If I'm dealing with the birth of the particle, then it tells you already, it's just creation, a creation expression. I'm going to stop them from being born if they're not going to be born in the right place. All right, so I'm going to go ahead and grab my lifespan peep expression on creation, which is right here, and it's very simple at the moment, but I'm going to make it a little bit more complex. I'm going to make a condition like we did before. So I'm going to say if, okay, the particle's goal V, when it's born, okay, is greater than, let's say, I'm just going to guesstimate it, right? So if this is 0, sorry, let's do it down here. If this is 0 and this is 1, and actually I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is perfect. I have 10 divisions, so it's easier to do percentages. So if this is 0 and this is 1, then this is 0.1, 0.2, 0.3, 0.4, and so on. So let's say that we want them just in this section here. So I'm going to say if my goal V is greater than 0.1, right, then my lifespan, let me just do my thing here, then the lifespan of the particle, I'm going to cut this out. Sorry, man, this goddamn keyboard that I got, it's horrible. Okay, so I just type lifespan pp. If that's true, then the life of the particle is 0. Okay? If it's greater than 0.1. Okay? But if it's not, then you put an else, then the life of the particle is going to be equal to 10 that we had before. Let's see if that's true. Perfect. No mistakes. And let's see what that does. Nothing. All right. Let's see why. Let's just double check this expression. So if goal V is greater than 0.1, so we're talking about creation, okay? The particle is this, and then it's fine. It could be because these expressions get evaluated in this order from the top to the bottom. And I'm assigning goal V at the bottom after I do this. So the first debugging that you can do is just take all of this, cut it, and then just paste it after. So they get evaluated after that. Hit edit, hit rewind, and hit play. And it works. And this is all done on purpose, just to show you that the expressions go in order, as if you were reading a book. So if you're already dealing with lives based on goal V, and goal V hasn't been assigned yet, then Maya doesn't know what to do, and just let it live. It will basically, this section here, this first condition, will return no, and every single guy gets a life of 10. As soon as you move it after the evaluation of this part, then everything starts to work. So right now we do get particles being born on the edge. They move along, which is great. They reach the end and die, and new ones come. And this is an endless system. It works really, really well. Let's save it. Let's tweak a couple more things. At the moment, all the birds are flying at the same speed. And here, even though we cannot see a particular bird on its own, I know for a fact that all of them, they cannot have the same speed. It's impossible. So let's randomize that. What dictates the speed of the particle as it flows along the surface? Is goal V on runtime, right? Is this particular number. Correct? Each one of them is getting the same speed. And that's not what we want. What I want is each particle to have its own speed randomly assigned near this number because I think this number works quite well for me. Perfect. So let's go ahead. How do we do that? Well, what I like to do is in lights of thinking of turning this into a setup and giving this to a client and flexibility and everything, what I like to do is create an attribute, okay, on a per particle basis. I want each particle to have an attribute that I'm going to create myself. I'm going to invent one for me. And I'm going to call this, for example, random speed. The name is irrelevant, whatever you like, as long as it's descriptive and short. So random speed is going to be a number. And that number is the one I'm going to be using to randomly assign it to each particle, right? So because it's a number, I'm going to use float. And the key of this, be very careful, is always select per particle. I want each particle to have an attribute that carries a number, or carries this attribute, right? So I'm going to hit OK. It shows up on my list. And now when the particle is born on creation, yeah, I'm going to grab my random speed attribute. I'm going to select it. That can be placed anywhere you like because it's just an assignment. So I'm going to tell each particle to have this attribute called random speed, which is going to be equal to a random number between 0.00, let's say 3 and 0.006. You can see what I mean? And on its own, if I hit edit, okay, nothing special is going to happen. I mean, nothing is going to change as far as the behavior goes at the moment. I'm going to rewind, hit play, so the particles are born again. And I'm going to grab one of them. I'm going to grab one of the particles. I'm going to go to numeric. And I'm going to tell them to show me random speed. This guy has 0.005. And you? 0.004. How about you? 0.003. Yeah? 0.003, 0.5, 0.4. Okay. So nothing goes below 0.003 and nothing goes above 0.006, 0.05 in this case. If you want to be more, have a bigger range, you can change it. But at the end of the day, you can see that each one of these guys have a different speed attribute. So that's good. But like I said, nothing's going to change. Why not? Because that's just information that the particle is carrying. We're not doing anything with it. Nothing at all. So the particle is born, and yes, it does have an attribute called this, which Maya doesn't even know what the actual name implies. And so, okay, fine, you got the information, but what do you do with that? Well, beautiful. Now, because you carry it at birth, and that's assigned to you, right? Think of it as your ID number. It's not your ID number. I don't want to confuse you with the particle ID. But that's going to be the number of pimples that you have on your face, right? Or the number of freckles that you were born with, right? So that's that. But as long as you don't use that on another expression or something, that is useless to have it. But if I go to runtime right now, and I tell the particle goal v, which is a per particle attribute, okay, to be as it is plus the number that each particle has with it, you can hit edit, everything is fine. Now each particle will have a goal v that is adding to itself a different number. And that's going to give it a different speed. And you can easily tell, because we made the range quite big, from 0.003 to 0.005 or 0.06. Then there are some particles that are quite slow, others are not that slow. And again, to make it easier for you to see, I'm going to make them spheres. And you just follow them. You see how much more natural it looks with just a simple change? Very simple, very natural. Start to do what it's supposed to do. We have a lot of control already, which is great. They're born on the edge. They're moving at a different speed. They die at the end. I think it's great. And I think we got a lot of control already. And it's a good point for us to turn this into a little system. We have done this many times, and every time I redo it, I'm going to do it faster. So I'm going to create locator. Let me just move around here. You give it as much control as you want when you do your homework. Your homework for this lesson is going to be, well, obviously to mimic this, but I would like to see it mixed with the other one, with the other setup from the previous lesson. So start to blend multiple attributes, multiple setups. Okay, so I got my emitter, my locator. I'm gonna go and do my usual stuff. General editor, channel control, get rid of all these things. Close it. Let's add some attributes. So swarm count is a float because it's just a number with a minimum of -1. We learned why already in the previous lesson. No maximum, a default of, let's say, 2,000 birds. That's I'm just thinking right now here quickly. Remember that I don't prepare these lessons and I go as a, go with the flow. Having this attribute with a set number of -1 and a maximum of 2,000, we said that it was for maximum count, so maximum number of birds. I'm gonna put it, okay? You can specify it later, but probably in a scenario with this kind of a setup, then you just wanna deal with the rate. And the rate will tell you roughly how many particles you have on the screen. Just thinking, right? It's not like the other one where the birds are just flying on the screen constantly. And you just want to have a few, overall density. In this case, because they're being born on the edge out of camera and they're just moving around the surface, then probably the rate will be enough. So I'm going to have a swarm count just to see, in case you want to have an exact number of birds, because again, we're preparing for everything. Anything can go wrong, and it will. It's like a Murphy's law, right? So that's why it's on the default value of this is going to be -1. So it's a minimum -1 and it's a default -1 with no maximum. So sorry, I'm going to leave that there. So the attribute has been created, and you shouldn't have closed it because I need more. So let's add more. And then what I'm going to say here, and I called it swarm, but well, whatever. You can call it whatever you want later. Swarm, let's say rate. Okay, this is definitely for the rate of the emitter. So minimum of 0, no maximum, and a rate of, I don't know, 2,000. Beautiful. We can say now, you can say random spin minimum. I'm going to see why in a second. It has no minimum, no maximum. I can say 0 as a minimum, no maximum. Default, let's say 0.003. You can kind of see where I'm going with this. I'm going to add also rand speed max. And the minimum is 0, and the maximum doesn't have, and the default is 0.005. Okay, so I get swarm count, swarm rate, random speed. What else can we put? Let's say swarm kill V. Minimum of, let's say 0, maximum of 1 in this case, and the default is 0.99. We can put swarm born V. I'm going to do a minimum of, let's say 0, maximum of 1, a default value of 0.1. Hit that. For now, I think it's good. So I hit close. Let me get this locator a bit bigger and a bit out of the way. And let's do some connections. The simpler ones. Okay, I got my locator here. The first one is the swarm count, meaning that I have to grab then my particles. We've done this before. Shape node, reloaded. And I'm going to grab then my swarm count, and it's going to be connected to the max count. Perfect. Swarm rate has to deal with the rate of the emitter itself. I'll grab my emitter, reload it, and swarm rate connected to rate. Swarm speed minimum and speed maximum. the idea of this attribute is to be placed onto the expression itself. This is the first one we're going to do this one. So we'll deal with those in a second. And kill v and born v are also the same idea. These attributes will go directly into an expression. They're going to be feeding the data onto an expression, which we've never done before. So right now the connections, the simple ones are done. Everything is simple, but the simpler ones are done. And this is good. I'm gonna grab my particles, and because I wanna have this thing handed over to someone, I'm gonna call this thing swarm. We can call this swarm, let's say swarm surface. We can call this guy swarm emitter. Thinking of always trying to hand this over to someone who doesn't know what you're doing, and then he needs to figure it out. Swarm control. Everything is named correctly. Everything is beautiful. We have it done. So now the question, the $1 million question: how do we pass information from these numbers here on these attributes directly onto an expression in here? Very easy. It's very, very easy. All you need to figure out is the name of the attribute on the locator. And for that, it's simple. You can just grab the locator with the expression editor open, and then find, for example, your random. Let's just start with from the bottom to the top. From the born v. I'm going to grab this, and that's the name of the attribute. Now I'm going to go to my particles. I'm going to go to the shape node, right? And I have the name of the locator. I'm just going to drop it down here so you can see it. So this is the swarm control dot swarm. So basically you can see here, this matches the name of the locator that I did. After the dot is the name of the attribute on that locator. And the born v, remember that is going to be the distance in where I want particles to be born, from 0 to whatever. And that is right here. I'm saying if the particles goal v when they're born is greater than 0.1, then kill it. So instead of saying 0.1, and this is what is called hard coding. Hard coding is putting numbers directly to an expression and limiting your expression to just that. But if you want to open that and give the user control over this value, then you replace that number with this attribute. So just, damn it, man. All right, this keyboard, I hate it. Okay, so I'm just gonna cut it. And instead of putting 0.1, I'm just gonna say this. And what it says is simple. It says if the particle's goal v position when it's born, remember, creation, when it's born, is greater than whatever this locator's control is telling me, then kill it. If not, let it live. Hit edit. You can see there are no errors. And this is the way to establish a connection using mail scripting. It's very easy. Don't worry about it. We're going to use it all the time. You may not catch it in this one. That's the virtue of a video. You can rewind and watch it again. Anyway, I'm going to do it again. Because I also have my swarm control kill v. And the kill v, remember that it was the distance where I wanted them, after they go past a certain point, kill them as well. That's what we're going to use. I'm going to grab this. Going back to my particles. Okay, and where do I kill them? I kill them later. I kill them on runtime. And I'm telling them this. I'm telling them that if the particle's goal v position is greater than 0.99, kill them. So instead of using 0.99, which is a hard code, I'm just going to place this. So if it's greater than whatever the locator's kill v attribute is telling me, then kill it. Beautiful. 2 connections done. What else I have? I have a spin min, random speed min and random speed max. So let's grab one, copy it. And the idea of this one is to, when we're randomizing this number here at birth, we want to have the user tell me what is the speed that he would like to use as a minimum and a maximum, and then let Maya interpolate that for you. So this is the minimum value. So instead of hard coding to 0.003, then you put this. And because I know that all I have, because I'm naming my things consistently, that's very important for you guys. Big tip for you. always try to keep a certain consistency on the names. Camel casing is extremely important. Remember the first letter being lowercase, and then the first letter of each following word to be uppercase. That is key, always, always. That's not even an option. Don't think any other way. But then keep on your own style with the naming. For example, I usually name my things like that. So I don't put random. I try to put a shorter. The attribute and then the characteristic of the attribute, if it's min or max, or the limits. I tend to work like this. You will find your own way of working. So that allows me to just paste the same thing, and I know, because that's the way I name my things, then it's consistent. You see, so if you start naming things all over the place, then you're gonna take a lot longer to work. So that being said, then my random speed attribute is a random between this value and that value. Everything else is the same. So let's see if it's true. Always save. No. Save. There we go. And let's test it. It looks the same, but now the beauty of this is that we can play real time. So let's see. Let's say that we want to change my swarm rate from 2,000 to 5,000. Then cool. It looks like we have a lot more points. Let's say that we want 1,000. You need to wait for particles to die, and then you start getting a lot less density here, you see? Or let's say that you don't want it anymore. You kill it. You can see that no more particles are being born. I like it. Beautiful. That works. The speed min and the speed max. Let's say that we want a crazy one that goes 10 times faster. Remember that they have to be born again to register the change, but then you can really see it. Like some of them go really slow, and some of them go really fast. And let's say we up the rate to 5,000 to see it even more. Yeah, that works. Beautiful. You can test the minimum. Let's say that the minimum is going to be even slower, 0.1. Then we start getting these little really slow ones. You can, when you test it at home, you will see. You start getting some that are really, really slow. And if you want to see it, you can just put this to 100. Clear the area. And then you will see some of them are just shooting, all across the screen, and some of them are really crawling along. There we go. Works like a charm. All right, so let's put this thing back to 1,000. Let's put these numbers back to where they're supposed to be. Okay. Let's put a bit more. 3,000. All right, cool. So everything is working. Let's test this last one. Let's say that I want the particles to die halfway through the surface. Look how cool this is. Then you can determine exactly where you want the particles to die and also where you want them to be born. Sorry, not 0.3. Let's say 0.01. Okay. Well, we're kind of killing them at the very, very beginning. Let's say that we put 0.4. Okay, so particles are being born in this section. We can specify also, if you want, another attribute. If you just want to say, let's say, clean some of this area and have them born right in the center, for example, from this section to this section, we can also do that. In this case, it's not really necessary, so this attribute is working fine. So perfect. Good. Kill V 0.5. We can just put it to 0.9. Let them move along a bit further. All right. I think we got everything working. The only thing that will be missing here a little bit, and I want you guys to explore that on your homework, is it's amazing, man. Especially because it's a plane that is divided in 10 pieces, and it's just very grid-like. It's very cool. So you can see the expressions right on time. So that's fantastic. You can see now here is the same thing with the name of the emitter, because I changed the emitter name. It's giving me an error right here. So let's see. There you go. It's just a little bug that is there. It doesn't register the name on the shape node until you put it. But as soon as I hit enter and the name here, it just takes it and the error goes away. I was saying that the one thing that is missing is perhaps having a little bit of turbulence or a bit of random motion on the other direction. So we have it here. Not all of them flow with the same speed. But what about we do something on this section as well? Let's add it. And with that, we've finished the class. So let's go to swarm shape. Let's go see what expressions we have for randomizing the speed. We have a random speed attribute right here. And we're using that on runtime to randomize the speed in V. But we're not doing anything to randomize the speed in U. I can show you one attribute, that, one expression that you can do. It's a bit extreme, but it's just a function that is built into Maya. So we can say goal U is equal, okay, to the noise of time. First time you see this one, noise. Noise is, imagine if you remember math from high school, that you got your sine and your cosine, and there's just almost like a curve that goes from -1 to 1 in a very smooth fashion. We can even open the web browser right here. Let's open a new tab and let's say noise function mel. And you will see this. That's noise. Okay, so it's a curve that has the limits of a sine or cosine curve, meaning that from -1 to 1. But instead of being a smooth curve like the sine is, it's a noisy curve. Like I said, this is a very extreme, but you're going to be using this function quite a lot in Maya. So the way it works is you specify, you call the function, but you have to give it something for it to move around. And time is a variable that is also built into Maya. I'm not saying that you're going to be using this one in the example. I will leave it up to you. I want that as part of the assignment. You can use a similar approach as I did with this, but instead of being V, you can be U, and see what that looks like. I'm going to do this one just to show you something new. So let's see what happens. They're freaking out. Look. Let's see it from outside, see what it's doing. It's too much. It's too much. Why? Because it's let me just show you. This is way too high. Let's just go ahead and multiply this by 0.1, for example, and just soften the effect of this. You'll still get particles stuck on the surface. It's a bit too much. Like I said, I don't know. This is a bit extreme. I just wanted to drop something to get your minds working, in between classes. So that's way too much. Way too much. I don't like it. What we can do is, let me just try something here. We're improvising, which is great. All right. I like it better. Damn it, it feels like birds flying. But they're all kind of the same. It's kind of annoying. They all kind of come up and down in the same way. But it is a start. I know how to fix it. I know how to clean it a little better. But because I'm not looking at the edges, just the overall behavior of the points, it gets me dizzy. All right, cool. That could be fine. We can, well, let me just explain what I did. Basically, I got my goal U, that's the one I'm messing with, on a runtime basis, meaning every frame I'm going to be messing with that number. I showed you what this function does. And on its own, it was a big curve from -1 to 1, very, very noisy. And it was pushing the particles too strongly to the top. I multiply it by this, meaning that it's 100 times smaller. That curve doesn't go from -1 to 1, but it's just a 1% of that. It's a very little curve. And instead of assigning that, I just say, well, add it to itself. So because it's such a little number, it's almost like having a 0.01 here. because it's such a little number, I'm just adding it to every frame. And because sometimes it's a negative value, because the curve goes to -1 and then goes to 1, sometimes it will subtract and sometimes it will add. I know this is complicated. This is lesson 5, and it looks like, it's not going to be like this all the course. I just wanted to, this class, mess with your brain a little bit. So I'll leave this for you to think about. If you're going to go this route, you want to explore something like this, but give me something. Yeah? Give me something. This is working, and I like it. I think one more thing that we're missing, and a couple things before we end the class. One thing is we haven't added then control. If we're going to use that expression and we're going to go that route, we need to add some control here so the user can specify if he wants that or not. If I want to use that turbulence. So let's add another attribute. We're going to call that swarm turbulence U, because that's the U direction. It will have a minimum value of 0, a maximum of 1, which will be insane to use, and a default of 0.001. So the control has been created, as you know. It's right there. We're going to connect that to the expression. So let's go ahead and do that. Grab my shape node. And then here, okay, on this here, we're going to put the name of the attribute. Because I'm lazy, I'm just going to copy this part, replace it right there. And it was called, I think, swarm turbulence U. Beautiful. Now you can tell if you want to use it or not use it. So let's test it. Let's grab the locator. Let's rewind, hit play. Let me just move out so you can probably see it better. And let's test and see if this works. Let's amplify this. That will be the easiest way for you to see if this is working. So they all move, up and down. They have some variation in between themselves because of the speed. But it does work. It does something. See if you like it or not. You can, like I said, try something new. They go all the way down, and they might go all the way up. There you go. This is way crazier. But it does the trick. So 0.001 is a good number. We have that. And I was missing one more thing. One more thing, and it's something we did with the class of the animals on the ground. So they're like the version of like this of that. Let me just return to. God damn it, man! These keyboards are driving me crazy. Jesus Christ. Okay. Let me just 1 second. Undo view change. Undo view change. Come on. Is what this? I'm just trying to get used to my new keyboard here because it's annoying. So what is this too? No. All right. Anyway, I'm just trying to get my camera back to where it was because I didn't keyframe it. So that's a good point. So that's my camera 1. Okay, cool. Now, one thing that I wanted to tell you at the end was the one thing that we're missing is having some thickness on this, because they're born on the surface. And because we said that with the animals, and it works with and especially this effect, is going to need some depth. Let me just hit back. Always refer to the reference. That part. It definitely has thickness. It's not just in one razor sharp line. And now we know how to add thickness. That's very simple, right? We grab the emitter. And we can even do it from here. We have a min distance and a max distance. So min distance, let's say -2, and max distance of 2. That's going to give this guy thickness. It might not be enough. Let's make sure, remember that the normal speed is set to something. Remember that's what happens with us, that happened with us with the animals. So same idea. Right now the speed is 0. We can give it something, so it registers the thickness. Still nothing. Let's find our normal speed is set to 1. Let's put the speed to 1, see if that does it. It won't do it. Right, of course it won't do it because the particles are gold to the surface. Okay, so that's something to talk about. When you have particle goals, then your min and max distance of the emitter itself is not going to work because the particles are going to attach themselves to this surface. Okay? If I want to give it some thickness and some offset, there is an attribute that you can use, but you have to find it on the list of attributes in here. So go to the per particle attributes, open the general tab, go into the particle menu here, and let's see if we can locate it. It's gonna be, I don't remember the exact name, but it's called gold offset, this guy right here. That's gonna offset the particle's position from the surface. It's still gonna respect the topology. So if this wasn't a straight, plane, it was just a curve, it will still respect that. It will use the normal of the surface to offset the particles and give them a bit of thickness. So I'm gonna be adding that. It's gonna be here, gold offset. And let's see what we can do with that. Let's go into the expressions on creation. Okay, when the particle is born, let's find our goal offset and test it. Let's just put it anywhere, somewhere there. Goal offset, and let's just see what it does. It is going to be a random number between -1 and 1, for example. Think of that as the min and max distance of the emitter. Let's see if that's true. Let's look at it from the side. Hit rewind and hit play. And beautiful. That is perfect candidate for an attribute to control in here. So I'm going to grab my control, modify, add attribute. Sorry, what am I doing? Yeah, sorry. This is going to be called the swarm depth, let's say. It's going to be a number. It's going to have no minimum and no maximum. And we need to do something else. Let's just think, right? Because if we put one number, it's the same thing that happened with the animals. We can either use one number to give that, use that as a multiplier, or if you want to give your boss control over the min and max distance, then well, you need to figure that out in a different way, because with the offset, it's not that really possible. I believe that there's no offset min and offset max. It's just always going to be a random number. So I'm just going to leave it as swarm depth. I think it will be fine. With no min and no max and a default of anything, I don't care. A default of, let's say, 1. Hit OK. So now this number that is on this attribute, which is set to 1, it has to go into the expression for this thing. Remember? So we're just going to do that. Go into the particles, find the goal offset, and open the creation expressions. Here's my goal offset. And it's a random between -1 and 1. That's perfectly fine. But let's go ahead and put a multiplier here and say multiply it by the control. And the name of the attribute, I think it was called swarm depth, I believe. If you make a mistake and if not that number, if you put, let's say you're missing an H, then it will tell you that attribute doesn't really exist. So you know that it's something wrong. And you see, I honestly didn't remember the name of the attribute, but because I always write them in the same fashion, then my brain tells me, okay, well, it should be this. It should be the name of the object and then whatever it does. So perfect. Swarm depth, it does work. So right now we have beautiful. If I grab my control, then let's increase that to 3. Okay, it does work. So it's a little thicker. It's wonderful. It does work. Great. So now let's look through the camera. Not this one. Let's just look through, let's say, the camera that I created, camera 1. Let's place that in there. Let's hide the polygons. Grab my points. Rewind. Save it. And it starts to feel like it, man. This is great. So it does work. Beautiful. We have absolute control, like is the motto of this portion of the course, so the prototyping. We have control over many, many things. What I want then for the assignment, I want you to recreate this, of course, give me the controls that we have in here, but also I want you to deform the surface. So the particles, so the bird will come in this direction and then turn to that direction as well. And I also want you to mix it with the other setup. So lame. You need to keyframe your camera, but there we go. Let's say that we want to import the previous one just to play with it and see what it does. It's this one right here. In import. You see what I mean? You can turn these guys into streaks as well. I'm glad I did it because it shows a bit of an issue here. We're gonna fix that in a minute. Let me just for now put that into points, and we have that. So we get a mixture of two systems. We need to work, of course, with the size of each one, but they start to give you a lot of complexity, which is great. Beautiful, I like it. Let me just open the scene before I didn't save it with this, so I'm gonna open that so we have when we end it. And here they go. And we had a bit of an issue, as I saw, when I put them to streaks. Okay, we have that. And that is caused because, remember, the streaks get longer based on the speed of the particle. So if the particle moves fast, the streak is longer. If it moves slow, at some point it will disappear. The particle won't even be visible. These are guys, the particles are being born, and they're kind of, for some reason, snapping to the edges. You can kind of tell here that they're all traveling and snapping. For some lame reason. We need to figure out a way to kill them to avoid that. So what we can do, let's just say we're gonna go back into object mode to pinpoint those particles and see what's wrong with them. See what the velocity is like. So I'm gonna grab the particles. Here's one of them, the problematic ones. We switch this to numeric. And we can put here velocity. And it will give you a value. And let's compare that value with another one that is not that, you can see that this is 3.5, 0.4, 0.19. And I lost the crazy one, but the values of the velocity were a lot higher. You see a numbers of 1,000, 69, and 28. So this guy is just flying around the surface. We need to come up with a way to kill this guy. And why is it doing that? I'm not really sure. There's a couple of reasons. They could be born somewhere there and just snap into the edge. Doesn't really make much sense to me. But I don't really care. I just need to figure out a way to kill this guy. So let's see. How can I do this in an easy way without confusing you too much? Let me just create an attribute on the particle. And I'm just trying to test it 1 second. Let me just think a little bit. What I will do, because I think this class looks really well to this point, and I'm worried more about the particle motion, not the rendering yet. So let's pause it here. I will come up with a simple solution for this, and we'll incorporate that into the next lesson. So I think it's best. But basically what I will do on the next, just to give you a heads up, is I need to find the magnitude of this velocity, and then if it's greater than some number, just kill it. At least for now. I will come up with a couple of other solutions probably and put them in the next lesson. So for now, I think to recap, redo what I did in this class, give me some control. Remember to give me some curve and have them turn into the other direction, right? And mix it with the setup from the previous week that is just lingering around. And post that in the community, I'm sorry, on the Facebook group, and then we'll go from there. And I'll keep an eye on this for the fix. So with that being said, well, thank you very much as always, and I'll see you in the next class. Goodbye.